In this question, you have to sketch the graph of this function, and remember this is the domain, so the domain of this function is R, and I'm going to start by finding the inverse. So to find the inverse, you always start by swapping x and y. So if this is y is equal to that, then by swapping x and y, that becomes y. X is equal to e to the 2y minus 1, and then you have to undo all of this and make y the subject. So first thing to get rid of is this minus 1, add 1 to both sides, and you get x plus 1 equals e to the 2y. And then to get to this power, you just take the log to the base e of both sides, and then this power can come down in front of that log. So the next step is log e of x plus 1 is equal to 2y times by log to the base e of e. This equals 1. Whenever you're taking the log of something and the base here is that same something, it always equals 1. So that becomes 2y times 1, which is 2y is equal to this thing. And then last step, getting rid of this 2, that will give me y is equal to, so I'm going to make that f to the minus 1 of x at this point here. And then to get rid of that 2, either divide both sides by 2 or times by 1/2, which I'm going to do. So timesing the other side by 1/2, and you end up with that's the inverse function. And I want the domain and the range of, or for that, that's a big R, a range for that inverse function. So to do that, I need to have the domain and range of the original function. So the domain is, as I've already mentioned, this first thing here, which is R, and then the range for that. It's a good idea to sketch a graph if you're not sure what the range is just by looking at that function. So a little graph here. Now this is a horizontal asymptote of -1, like that, and the graph does something like that, and it actually passes through 0, 0, so I'll fudge that a bit. And I know that because if I look for the y-intercept, and it doesn't actually really matter at this point to figure out the range, because the graph is a basic e to the x type graph and then move down 1. So that's your basic e to the x graph, move down 1, and this is y equals -1. And you can see from that that the lowest y value is -1, and then it shoots up towards positive infinity. So they're both round brackets. So that's the domain and the range. So now to find the domain and range of the inverse, all you have to do is swap these two. So the domain becomes -1 to infinity, and the range becomes R. So this is the inverse function here. And now to sketch it, there's the axes, and I've drawn in the line y equals x because I'm going to put the original graph on there and then reflect it in the line y equals x. So there's the graph of y equals e to the 2x minus 1. As I said before, it's your basic e to the x type graph, which is going like that, where the x-axis is the asymptote, and then it's moved down 1, and there's the horizontal asymptote, which is y equals -1, and it's passing through 0, 0. As I was starting before, the y-intercept, you always let x equal 0, and then you would get y equals e to the, and that would become 0, and then -1, and so that equals 1 minus 1, which equals 0. So it's definitely passing through 0, 0. So I'm going to mark that point in slightly darker green. And then it's also the graph, the original graph also comes back up through the line y equals x again. So what that means is that when you reflect that graph, the inverse is going to also go through those 2 points. And it's a key thing about inverse functions. They cross the line y equals x at the exact same points as the original function. And I'm going to do that now. And there's the graph of the inverse, that bright green one, and it's passing through 0, 0, and it is coming back, bending back towards the line y equals x, not quite in the exact same shape as this one here, which it should be. If you were to do this in an exam, you would get marked on the accuracy of it, so it's not quite accurate. So I'll leave it at that, and we'll just say that that point up here is on the line y equals x, is where the inverse goes through and the original function. So the other thing that happened was this horizontal asymptote got reflected here and became x equals minus 1. And again, just swapping the x and y here to get that. And there is the graph of the inverse function. And you can also see that the domain, the set of x values, go from minus 1 up to positive infinity, which is what it says here. And the y values go from minus infinity up to positive infinity, as it says here with r. So this is the graph of the inverse function, this green graph here, and if you were asked to sketch them or sketch it on the same set of axes as the original graph, you would leave it like this, and of course you would label it f minus 1 of x like that. Just to be clear, that's that one right there, and this one is that one there. And that would be the answer that you would give. Now, if you just had to sketch the inverse on its own, you could do it like this, and I'll show you how to do that on another set of axes. So first of all, with your log graphs, they will always have a vertical asymptote. And the easiest way to find it is just to let this equal 0. So if you go x plus 1 equals 0, then solve that, you get x equals minus 1, and that's the equation of the vertical asymptote. It's just a normal log graph. This is a dilation factor, but the important thing is the vertical asymptote. So I'm going to set up the axis and continue sketching like that. And so the graph's going to do something like that, being a positive log graph. And I don't know where it's going to cut here. So what I'm going to do is find the y-intercept. It's always the easiest one to find. I've actually done that in the other part, but if you just had this equation and I hadn't worked it out before, y-intercept x is 0, so you would get y equals 1/2 log e of 0 plus 1, which is 1, and then that's 1/2 times log e of 1 is 0, so that equals 0. So it's passing through 0, 0. So now I'm going to draw the log graph like that, and it is passing through 0, 0, so I'll fudge that a little bit there, and voila, there's the log graph. The inverse function f minus 1 of x equals 1/2 log e of x plus 1. Alright, so that's kind of the easy and quicker way of doing it. So moving on to part B, and you have to show that f of f minus 1 of x is equal to x. So the left-hand side is equal to f of f minus 1 of x, and that just becomes f of the original function, which was, sorry, the inverse function, so which is 1/2 log e of x plus 1. And then all you're doing is subbing into the original function, which is y equals e to the 2x minus 1. So into here, where that x is, you're going to put this function here. So it becomes, so this function becomes e to the 2 times then all of this, so 1/2 log e of x plus 1, and that's another bracket, and then minus this 1. And 2 times 1/2 equals 1, so that becomes e to the log e of x plus 1 minus 1. And then when you raising e to some power, and that power is log to the base e of something, then all of that just becomes this something. If there was a 2 here, you would have to put that 2 in here, and that would become x plus 1 squared, and then all of that would be what the whole thing would become. But you've got to make sure that the number here is a 1 to do this. So this just becomes x plus 1 minus 1, and that equals x. So that equals the right hand side, or you could just do this if you wanted to, as required, like that. And just on that point here, So let's say you had e to the log e of 2. If you do that on the calculator, you'll find that that equals 2. And again, you just got to make sure that this number here is a 1 if you're going to do it without using a calculator. So that's how you do this second part, part B. Not as hard as it looks. Sometimes when students get something like this that's a bit foreign maybe, or they haven't seen it before, or they don't know what to do, they don't actually write anything on the page. And that's something that's really important. When you don't know what to do, always write the thing that you're trying to find down on the page in front of you. And sometimes from that, just doing that, you can actually see what to do next. Whereas if you don't write it down, it tends to just be in your mind, and it's not as easy to figure out from there. So that's how you do part B. And here's the graph of the inverse function. One final comment here, make sure you do to the -1 as I didn't the first time. Sometimes when I'm explaining stuff, I just write the wrong number or the wrong something, and I don't see it till I'm editing. But anyway, well done if you've spotted it. So just make sure that you have the -1 when it's the inverse and not the dash that I had before, which would mean that it would be the derivative function, which it's not. That's it for this lesson now, and I'll see you in the next one.